Hi everyone, my name is George Corbeil. I've often been asked to explain the difference between PSIA and PSIG. So here's the difference as I see it. On this slide you're looking at the Earth with a thin blue ring around it. That's the atmosphere surrounding our home. The atmosphere has a mass and the Earth has a mass, and so they cling to each other by a force called gravity. It is said that if two ships were left adrift on the ocean, they would be pulled together. Two masses will always be pulled together by gravity. It's a good thing because our fella on the right would fall off the Earth. The moon is pulled toward the Earth and the Earth is pulled towards the sun by each other's gravities. Because they're spinning around each other, centrifugal force keeps these masses apart just right, similar to swinging a bucket of water over your head. Let's hope the spinning never stops, else we could be in a lot of trouble. Dr. David Suzuki once said that if the Earth was the size of a basketball, the atmosphere would have the equivalent thickness of saran wrap. We don't have much. That's why atmospheric pollution is so scary. Although the atmosphere is only about 70 miles or 113 kilometers high, it has been calculated to have a mass of approximately 5 sextillion tons. That's a 5 followed by 15 zeros. But if we were to imagine a 1 inch by 1 inch column of atmosphere, from sea level to the top of the atmosphere, the mass of that column would be 14.696 or 15 pounds. This is arrived at by dividing the mass of the atmosphere by the entire area of the Earth's surface. So every square inch exposed to the weight of the atmosphere will be subject to a pressure of 15 pounds. In other words, it can be said that every surface at sea level will be subject to a pressure of 15 pounds per square inch or 15 PSI. Obviously, the pressure will be less at a higher level, say on top of a mountain, since the column will be shorter. Air has an affinity for water. We know that at times the air can be more moist than at other times. But for water vapor to enter a column of air, some air must be displaced because no two entities can occupy the same space. It is interesting to note that the mass of the water vapor entering the column is less than the air displaced. Hence, the now moisture column will weigh less than when it was dry. If a weather forecast indicates a low pressure coming into the area, that air will most certainly contain a lot of moisture. Here we have an open plastic bag. The bag has no tendency to explode or implode, since the pressure on each square inch of surface is equal, both on the inside and the outside. Does this mean that there is a pressure of 15 psi exerted on every square inch of our body? Yes, it does. But there is an equal amount of pressure exerting outward as well. If an astronaut didn't wear a pressure suit, maintaining a 1 atmosphere pressure while floating in space, his or her body would explode. The one exception is our pleural cavity. As we expand our chest muscles, thus increasing the size of our lungs, the pressure inside drops and the atmosphere rushes in to fill the void. We call this breathing in. A vacuum cleaner is designed to remove the atmosphere from within itself and discharge it elsewhere, say a dust bag. New atmosphere then rushes in, pushing any dust or other material in its path ahead of itself. So in fact, those little dust bunnies are not being sucked in, they are literally being pushed in. Here we have an empty gas cylinder equipped with a pressure gauge which reads 0 psig, because it's empty. As with the empty plastic bag in the previous slide, although the cylinder is empty with the valve open to the atmosphere, there is a pressure of 15 psi both inside and outside of the container. Now let's close the valve and take the cylinder above Earth's atmosphere. Here we have no inward pressure on the container, but since the valve was closed before we left, we still have 15 psi pushing outward on the cylinder's wall. Now let's open the valve and allow the trapped atmosphere to escape. The cylinder is now subject to absolutely no pressure whatsoever in either direction. Now let's close the valve and return to the Earth's surface. While the valve remains closed, the cylinder's internal pressure will be absolutely zero, a perfect vacuum, and it will now have a tendency to implode since it is once again subject to an inward pressure from the atmosphere of 15 psi. If we were to now open the valve, the atmosphere would rush into the cylinder, much like the action of the vacuum cleaner. When measuring pressure, we tend to measure any pressure above 1 atmosphere. Any pressure below 1 atmosphere we classify as a vacuum. These pressures have values expressed on the PSIG scale with references to the pressure of 1 atmosphere as being 0.0. In fact, the absolutely true scale should reference a point where there is no pressure whatsoever, for instance above the Earth's atmosphere, and that point should be 0.0. In this case, the values would be expressed in PSIA. There are gauges similar to the one shown on the screen which can indicate the entire true pressure beginning at 0 PSIA, or 30 inches of mercury vacuum, while most other gauges only measure pressures above atmosphere. In conclusion, regarding pressures above 1 atmosphere, PSIA readings are 15 psi greater than PSIG readings. So this is the difference between PSIA and PSIG as I see it. Thank you and have a good day.